So welcome to this Edexcel Further Math Statistics 1 video looking at examples of type 1 and type 2 errors. And this slide just reminds you of the definition of a type 1 error. The example we're going to look at is quite long and has got a lot of information in it, so I suggest you pause the video at this point, read it through carefully and make notes on the information that you've been given. The hypothesis test involved is to be carried out on a mean and to see whether the mean is 42. So our hypotheses will be h0 mu equals 42, and it's a two-tailed test, so the alternative mu not equal to 42. So the other bits of information I hope you noticed were that times to be cured are normally distributed. We're given the population standard deviation, not the variance, so make sure you remember that. We have a sample of 64 people involved, and we are given the two critical values for this test. And what we need to do is work out the probability of making a type 1 error, or work out the value of the significance level for this test. So in order to find that, we need to just remember that the distribution of the sample mean will have the same mean as the null hypothesis suggested, 42, but the variance will be the population variance divided by 64. And with a type 1 error, we are rejecting the null hypothesis when the null hypothesis is true, when mu equals 42, and so we are going to have to work out the probability that a mean falls in these two extreme regions. And if we add those two probabilities together, that will give us the significance level or the probability of making a type 1 error. So very simply doing that on a calculator, we can evaluate that each tail is 0.0253, and therefore the required value for alpha, or the probability of making a type 1 error, is going to be the sum of those two probabilities. And so the probability of making a type 1 error in this particular scenario is 0.0506. So the second example again looks shorter, but actually has got quite a lot of sophisticated information here. So again, it's worth pausing and just reading through what we are given. So again, note that we do know that the times are normally distributed, and we know the original mean and the variance for that population. The question asked us whether the mean had changed, so our hypotheses will be mean equals 78 or not equal to 78, a two-tailed test again. And remember, you did meet hypothesis testing for a population mean in section 5 of the statistics at A level. And the information we have about a type 1 error is the probability of making a type 1 error must be less than 0.01. And that implies the probability that we reject h0 when h0 is true must be below 0.01. So looking at the fact we want the type 1 error to be less than 0.01, type 1 error is rejecting the null hypothesis when the null hypothesis is true. We want that to be below 0.01, so for this two-tailed test it means we would have 0.005 each end, 0.99 in the middle, and it's probably easiest just to find the two z-scores where the probability of lying between plus and minus the z-scores is 0.99. And you should fairly easily obtain the value 2.576. And because we're told we have a random sample of n with a mean time of 79, 79 is above the mean that we are testing for, 78, and that must mean that we are looking at a positive z-score. So that means that 79, when we standardise it, and remember to divide by the standard deviation, which is the square root of the population variance divided by n, that must be greater than or equal to 2.576. And having got to this point here, and I know it's quite complicated thinking through how we got there, having got to this point, it's a fairly straightforward inequality to solve. Remember, you're going to be squaring because it's root n greater than or equal to 3.864, and you should find when you square that we need a sample size of 15 in order to have the probability of making a type 1 error below 0.01. So again, that's quite a complicated example, worth pausing and going back and just perhaps running through that again. And this slide just reminds you of the definition of a type 2 error. So this example is one we looked at, and the new part that we're going to look at this time gives us the information that in fact we know the actual mean time was 41.2 days, and we are going to find the probability the test results in a type 2 error. And if you recall, our initial hypotheses were that the mean was 42 or the mean was not equal to 42. So in the question we were given the information about the two critical values for the sample mean for this test, and for type 2 error we want to accept the null hypothesis, so we want to fall within those two values, given that the mean isn't 42 but it's actually 41.2. And remember, the information in the question that you looked at in part 1 was that a sample of size 64 was obtained and the hypothesis test carried out on that. So all that is required is to work out the probability of getting a sample mean lying between the two critical values when the population mean value is 41.2, is now a different value to the one the null hypothesis stated, and our standard deviation will be the square root of the population variance divided by n, the sample size. And you should be able to evaluate that probability very straightforwardly directly from the calculator. And if you like, you can go back and just remind yourself of the entire example that we looked at in part 1 of this video. So our actual value for the mean is not that different to the value we were originally testing, 42, and the probability of a type 2 error here is 0.703, which is relatively high. So this second example is one looking at a test on a population proportion. So again, I suggest you just pause the video, read through this example and make notes on the information that you've been given. So think about what the hypotheses would be and think about what we need to happen to result in a type 2 error. And clearly the null hypothesis is p equals 0.7, and we wish to investigate whether p is greater than 0.7, so our alternative hypothesis is p is greater than 0.7, and for a type 2 error we want to accept h0 when h0 is false, And you'll notice that with a type 2 error we always need more information about what actually is true, and in this case we're told that the actual true population proportion is 0.8. So the original model we're dealing with is a binomial model where n is 14 and p is 0.7. 0.7 is given to us as our null hypothesis value for p, and we're looking at 14 customers. It's a one-tail test, so we're looking at the number to equal and exceed, so the probability that x is greater than or equal to that particular number is below 0.05, and that's because we have a 5% level of significance for this test. So you may need to go back and just revise binomial proportion testing that you did in your A-level or AS level maths. And in fact, the probability of getting 13 or 14 customers preferring the new site out of a sample of 14 is just below 0.05, and our critical region is 13 and 14 out of 14. So having worked out the critical region, and that's a step we really do need to do, because we need to work out for type 2 error the probability of not falling in the critical region when the true proportion is actually 0.8. And so the probability of not falling in the critical region is the probability that we have between 0 and 12 people preferring the new site out of our sample of 14, given that the true proportion of people who prefer the site is actually 0.8. And that can be quite simply obtained on your calculator using the cumulative binomial function. The probability of getting up to including 12 is 0.8021, and that gives us the probability of making a type 2 error. And that concludes this video. The next video will look at size and power of a test.